All right, I don't really like the formula, so I'm going to put it into the TVM solver version. The D here represents a deposit. And the deposit, what's big about annuities, and the difference between annuities and the problems that we've just done, is that annuities involve not just one investment at the beginning and just watching it grow, not one lump sum at the beginning, but rather annuities are such that you're going to make a regular payment. Very few people have $10,000 to invest and watch it grow over 40 years. However, everybody can put $100 away in each one of their paychecks each month until 40 years have passed. It's investing these little amounts is the way we typically invest. So when you get a job somewhere and they send you your check, you can say, hey, just take $100 of my paycheck and put it into my 401k or put it into my investment. And most employers will do that happily. All right, I'm going to change this a little bit, slightly. I'm not going to change the R's and the N's and the T's in here because those all have meanings. We know that, for example, the N is the payment per year and the compounding per year. You can see it right here. In our example, if interest is compounded monthly, then both of these numbers would be 12. If interest is compounded daily, but now the P/Y has meaning because the P/Y means payments per year. All right, well, and generally you compound the interest at the same rate that you make your payment. You make your payment at the end, interest is compounded. So these numbers still will be the same, but the payments will be made monthly. That means they're made 12 times during the year. That's the compounding factor. And we know that R is equal to as an example, if it's equal to 5%, I% is equal to 5. So we're going to put in the formula, we would put the decimal version, but in the TVM solver, we're going to put the percent version. The other thing is that instead of A here, I'm going to use future value. That's the variable in here that we use. So the A was like the future value in our simple interest formula, in our compound interest formula, that A that appeared on the left side, that was what we're going to have in the future. Here they use function notation and they switch it up a little bit. And so it might be clearer if we just use future value or A. And the other one is this one right here. This is going to be our regular payment. If we're investing or making payments monthly, then this would be our monthly payment. If we make payments quarterly, then this would be our quarterly payment. But it's that regular payment that you make, which makes it an annuity. So in fact, what's going to happen here is we're not even going to use this formula much. I'll probably go through a couple of them just so you can see how tedious it is. But generally, we're going to use the TVM solver. And if you have this powerful tool, you can solve many more problems in the math of finance than if you had to do everything with formulas. All right, so A is the balance in the account after T years. So the future value is the balance in the account in the future after T years. D, which is the payment, is the regular deposit or payment. They say deposit because if you were the one doing the investing and you're putting away a certain amount of your income, then we would refer to that payment as an investment. Whereas if you were making a payment on a loan, then it would really be a payment. So I guess they're calling it deposit because that's a word that we use in economics and finance. And it's the amount you deposit each year, each month, and so on. We're just going to call it the payment. And these others have not changed from our earlier formulas in meaning. Okay, in case you forget, if you want to know where the TVM solver is on the calculator, here are the 3 keys you need to press. All right, so one problem we can do is we can ask, what is the value of an annuity? So the value of the annuity is the future value. By the way, when we invest over 40-year periods out of our paycheck, we usually start with nothing. And so we're going to assume in our problems that we start with nothing and then we just start making payments. And because of that, in all of these problems, the present value of the TVM solver will be 0. We start with 0. Notice that there is no spot up here in this formula that says the present value. There is no p-value. The p-value has been replaced with the payment value. All right. You can see here, this is the periodic deposit. We're going to say that that's the payment. It can be the investment, but the TVM solver notation is our investment, our payment. So the payment is equal to 60, but because it's cash out, we're going to put negative 60. It's a payment that's being made each month, so the compounding factor is 12. That leads the payments per year and compounding per year both to be 12. All right, so we get those two from the first piece. Then we go to the next piece. The interest rate is 5%. If we use that and put it into the formula, it would be 0.05, but I%, what we put into the TVM solver is the percentage of the rate. So we're not going to convert it to a decimal if we use a TVM solver. And then the last thing is the T, which is the 30 years. And T is always in years. So if they give it to you in months, then you have to convert it. All right, I'm going to use this worksheet here for this information. Now, N is equal to the number of payments. So over 30 years, if you're making monthly payments, you would have 12 times 30. And N is always equal to our compounding factor times the number of years. All right, and 12 times 30 is 360. I percentage is 5. The payment, there's your negative 60. And the future value is also known as the value of the annuity. And that's what we're calculating here. Payments per year, compounding per year will be 12, and then interest is going to be calculated at the end. All right, so when you look at all this information that was given, this is what you have. The other piece is that the present value should be 0 in these problems. So we're going to put 0 there. And that's what you need. No algebra, it's a matter of finding these values, plugging them in correctly, and then doing an alpha solve on the one that you're missing. All right, so I've got everything in exactly as appears over here. The one we need is future value. So go there and then hit the alpha key here, and then the enter key. And that's what you have, a cool 500,000 it looks like. No, not 500,000, 50,000. All right, so write down what your calculator gives you and then answer the question. And that requires that you round that answer and you put the decimal or the dollar sign in front. Okay, we're right about at halftime, so why don't we go ahead and take a break? We come back, we're going to work on more problems, and we're going to mix them up so that instead of always looking for the future value, we're going to be looking for one of these other guys. All right, I'll just kind of run through these, and maybe you've done it as well, but just so that you have a couple of more examples. There's nothing really new in the rest of these problems. They just have different inputs. And so for part 8, we have the payment is negative 150. 150 at the end of every 6 months. Okay, so every 6 months, we would have one payment after 6 months and then another payment after the next 6 months. So in a year, there's going to be 2 payments. So payments per year would be 2. Said another way, we would say that the interest is compounded semi-annually, twice a year. And the payments per year and compounding factor per year is always the same. So compounding will occur as the payments occur. All right, so that takes care of those two. 6.5%, we just enter that percentage in, no need to convert it to a decimal. And there you see the semi-annually again. So that confirms that we have M is equal to 2. 25 years, that's the value of T, but remember we need to multiply that by the M, the N, compounding factor, 2. So over a 20-year period, since payments are being made every 6 months, that's 2 payments per year. 2 payments per year for 25 years would be a total of 50 payments. And N is always the number of payments. You're always going to have this present value wondering what it is in these problems. But again, the idea is that we start with nothing, and the only thing that's going to be in this account is the $150 that we put there every 6 months. All right, do a quick calculation in your head, or your calculator if you want. You're contributing $150, and you're doing it twice a year. And you're doing that for 25. So that's $300 a year, and you're doing that for 25 years. And so the only amount that you've invested is $7,500. Now you can't expect $7,500 to grow to $1 million, but it's going to grow, but it's just not going to grow like, some of these other numbers that we've been seeing. So let's see what 75,000 grows to. All right, I'm going to go back to the TVM solver and put in all the values for this problem. All right, so it matches the inputs that we have. And then we're going to come back to the one we want to calculate, which is the future value, and do alpha solve. All right, one thing I haven't done that I'll do with this problem is I'll calculate the interest as well. Now remember, we've only contributed 7,500 here, and that grew to more than double that. Double 7,500 would be 15,000. And this account over 25 years grew to 18,225. All right, I'm going to put that number in here. 18,225.39435. And then I will interpret that answer by putting the $ there and then rounding to the nearest penny. I forgot to do part B in these problems, which is find the interest. Now, you're not going to use the TVM solver to find the interest. You're basically going to say, okay, how much did I pay and how much is there? The difference between what my principal, what I actually paid, and what is there is the interest. So the future value is equal to the principal plus the interest. We calculated the future value, and then if we subtract total investments, and we'll call that the principal. How much principal did you put up? Well, we had 360 payments in this case, and we made $60 payments. So that's this amount. 21, oops, got the comma in the wrong spot. 21,600. So if we take the 49,935.52 and subtract what we invested, everything else would be interest. I'm not punching numbers into the TVM solver, I'm just doing the subtraction. But what you should know is that you can do calculations in any row. So I'm just going to do this calculation up in the top row. All right, so this amount, actually we earned more interest over this 30-year period than we actually contributed ourselves. We contributed 21,600, and the interest we earned was 28,335. In the second problem, we invested 7,500. That was our $150 payment that we made 50 times, twice a year over a 25-year period. And so the total interest would be the subtraction of those two numbers. So 39,525, and then 10,000. That's a 7. Okay, once again, over a long period of time, I think what you'll find is that the interest that you earn by investing will be more than what you actually put in. And that's why we do it, because it's a moneymaker. It's earning income when you don't even have to work. You just take this money and from your regular job and just put a little bit away. It doesn't have to be a lot. It can be $60 a month, $150 every 6 months, and it really grows. All right, so you're going to see just a bunch of problems kind of together. This one was just trying to find the value of the annuity, and that is trying to find the future value. Each group of problems will ask you to find a different thing. All right, so let's take a look at this next grouping. It says determine the periodic deposit. All right, remember that the periodic deposit in the language of our textbook here, this is the regular payment that you're making. When you go to the bank, you make a deposit. You put a money in. If you go every month and put money in, that's another deposit. Just think about that as a payment or an investment. So in these problems, we want to know what this guy is. So that means we have to know everything else. But like all of our other our first three problems, we're going to assume as we're investing that we start with 0. And so that's why we're going to let the present value be 0. All right, so the periodic deposit, this is the payment. And it just doesn't give us the payment, but it does give us an important piece of information at the end of each year. So there's going to be one investment, one payment, one deposit made at the end of each year. That's confirmed over here where it says the interest is compounded annually. And that means that the compounding factor is 1. So the payments per year and the compounding per year will be 1. The time is 18 years. This is the value of t. And so that helps us with n. N is always little n times t. We know that the t is 18 years in this example, and down here is n. So 1 times 18, or just 18. So when the interest is compounded 1 time per year, then the value of n is going to be the value of t. We have, we're doing number 12, and we have 5%. So we're going to enter in the I%. The future value here, they give us a target. This is your financial goal over here. So the implication here is that in the future, are you going to meet your financial goal if you invest this amount of money? And so future value is this column over here. And it goes in as a positive number because, you know, at the end of the 18 years, we're going to take that money out, and that's money coming in. All right, and let's plug it in, find out what the payment should be, or the investment. All right, I gotta type these things in, 18 and 5 and 0. And all right, the sad news here is that if you make one little error on any one of these rows, the whole problem's going to be wrong, because it basically takes these numbers and plugs them into a formula. And let's see, how much do you have to invest each year to come up with $150,000 at the end of 18 years? And there it is, 5,000, just a little bit over 5,000. And then we'll report the answer. We're not bothered by the negative. We understand that that means cash out as we make our regular payments. Okay, I got to go back and read. It says, this one says round to the nearest dollar. Generally, we're going to round to the nearest penny, but if we rounded to the nearest dollar, I guess it would be 32 to the nearest dollar. These problems always ask, just so you kind of realize that a lot of this money, especially over a long period of time, a good chunk of this money that you have in the future was money that you earned via interest and not the actual money that you put in there. And so they're always going to want you to calculate the interest. And so I can give you a formula here. It's not a TVM solver formula, but it's this. Total investments equals principal, your payments, plus the interest. I did a subtraction in the problem before, right? So total investments plus interest, that equals the future value. And that amount is equal to your periodic payment. I just say periodic because sometimes it's monthly, sometimes it's quarterly, sometimes it's yearly, times the number of times you made that payment, or future value. Okay. Oh, sorry. This one here is, I think about this. Your the money that you have at the end is made up of the principal plus the interest. And your principal would be this, let's see, this payment of 5331.93, and you made it 18 times. The future value was $150,000. All right, I'm getting messy here. So maybe I'll write it somewhere else. All right, so continuing, we have $150,000 is equal to 5331.93 times 18 plus the interest. And so we can figure this amount out and then subtract it from both sides, and we get 95,975.64. All right, and so if you subtract the 95,000 from both sides, 150 minus the 95,000, that's going to give you the interest. Okay, so putting it all together, our goal was to have $150,000 after 18 years. We saw that if we got an interest rate of 5%, all it would take is a little bit more than $5,000 a year. Our total investments turned out to be close to $96,000. So we put $96,000 of our own money, over $5,000 a year for 18 years, totaled this amount of money. But at the end of the 18 years, the account had $150,000 in it. So therefore, the rest of the, I mean, if this is what we contributed, the 96,000, then the rest of it must be interest to make up the 150,000. So you just do a subtraction. This is part B that they want in each problem. Okay, why don't you try 16? And go ahead and put your answer in the chat when you're ready. Number 16. Here it looks like you have monthly investments. You don't know what, but your financial goal is $1.5 million. Boy, you're probably going to have to invest a lot every month to get $1.5 million after 40 years. Just to give you a kind of a comparison, if you invested $5,331 per year, then that, if you divide that amount by 12, then this would be your monthly investment. So that's why these two amounts are more significant. You know, you should find a payment here that's probably less than $1,000. I don't see any answers yet. So what this problem consists of, and all of these in this section, is to just fill in all but one of those all but the payment, and then do an alpha solve on the payment and write it down. Some of these are easier than others, right? Like the interest rate is almost automatic because a lot of times they just give it to you in the problem. Now, you have to remember to write it as a percent. If you put in 0.0825, which is what you'd want to put into the formula, then that would be correct, but it's not correct when you use a TVM solver. Monthly, compounded monthly, that is 12 times a year. So those take care of 2, and this is always end. We're getting there. Some of these are easier to find than others. I need to have you make mistakes now in class so we can correct them. 151.5 million, that's what we want to have in the future. Well, we know that we need to find the payment, so we need to have a value for this n up here. Okay, n is always N times T. Always, every single time. The N value is down here, the monthly. So it's 12, and then the T value is 40. So this N value that you type in has to be 480, because you're making monthly payments. You're making 12 monthly payments a year over 40 years. So in the end, you're going to have made 480 payments, monthly payments, to make up that 40 years. Okay? Get out your TVM solver. And I see we need to do some more of these. So we'll do the one in the middle as well. 480, 8.25, 0. I'll skip the payment. 1500000, and then change these numbers to 12. So this is what everything looks like before you go and calculate the payment. Okay, I see a couple of good answers there. Yeah, so it looks like 400 or 399 is the choice. Let's take a look. Yeah, there it is. It only takes $400 a month. It's a very nice investment of 400 times 12. That's 4,800. That's close to $5,000 a year. That's a nice investment. But just think about it. If you take this payment of $399.58 and you make it 480 times, 399.58, and if we make it 480 times, what actually has left our pocket, this is our money, right? We're investing it, and multiply those together, and you get this amount of money. Now, this is quite remarkable if you think about it. The number one thing that's remarkable is that you saved $191,000 over 40 years while you were working. Congratulations. But what's even more significant than that is that money grew to $1.5 million. You don't only have the $191 sitting in your nest egg, you have a 1.5 million. And with 1.5 million, you can pay yourself about $7,000 or $8,000 a month for the rest of your life. You'll never need to worry about having any money in your retirement if you do this. It takes about $5,000 a year over a significant number of years. Just do it while you're working. All right, so then if I subtract these two numbers, this was your principal. That's what actually came out of your pocket. This is the future value. This is what's actually in the account. If you subtract those two numbers, you get $1.3 million. $1.3 million was interest. You put your money to work, and your money came through for you. The problem is that most people don't do the hard work of investing every month. Got other things to spend that money on. Can't worry about retirement. Got a vacation I want to go to. Okay, I'd like to see, looks like we got a couple of answers there, but I want to see more correct answers, right? So let's try it again. Let's try it with number 14. Put in the inputs, calculate what you're going to have in the future value. And I think, just getting used to this TVM solver, pretty soon you're going to be reading these problems and you're going to be dumping values into the TVM solver, and you're going to have them mostly correct. And, you're going to be able to fly through this homework assignment. It just takes a little practice to know how to translate the words into values that you can dump into the TVM solver. Okay, put your answer to number 14 in the chat. Particularly what payment will lead you to your financial goal. And here the financial goal is $250,000. All right, so let's say if I decided to work another 10 years, I could have $250,000 at the end of those 10 years saved up, even at my age. All it requires is a minimum monthly payment. Please help me. What is that minimum payment? What do I have to do? How much do I have to put away each month so that I can meet my financial goal? You're my financial advisor. We would, if you were making monthly payments, but for number 12,
Oh, okay.
we were just making one payment per year.
Oh, yeah.
So it's always, but it is always n times t. It's just at the end is 1 in this example instead of 12.
Annually, okay.
Yeah. I mean, when you're actually investing for yourself, probably the 12 is what you want, because, or even every 2 weeks you can take something out if you want. All right, I'm seeing a lot of the same answer, so that is good. Here, 14 is another monthly, and so we got to take 12 times the number of years, 10. So you should get 120 up here. And then both these numbers down here are 12. Our targeted amount, 250,000. The payment is what I ask you to find for me, and the interest rate, 7.5. And you'll find that we actually use the same annuity formula. A lot of times we think about this context of future value annuities as being just investing for your future, but you could be investing for something short term, like if you're a grandparent at some point and you want to start a fund for your grandchildren in terms of their college. You can maybe plan to save a certain amount for 18 years, so when they're 18, you'll have money saved up for them to go to college. So here is one such problem, and it's much better for you to save money in an investment so that all the interest that is earned actually goes into your account, as opposed to taking out a loan, because when you take out a loan, interest still has to be paid, but it's paid to somebody else. So if you have a financial goal that you want to have a chunk of money in the future, that's called a sinking fund. And it's how a lot of schools or counties or cities save money in their, or raise money in their millages. They say, we're going to have a bond proposal. We need to build this new natatorium in the city, and we need your help, taxpayers. And so we want to establish the sinking fund. We want to build it in 10 years, and in 10 years, we need to have $7.5 million. So this is how much we have to collect each year. So they set a financial goal. They get the money from each year from the taxpayers, and then when the 10 years pass, they'll have 7.5 million, but they're saving that money and they're paying themselves the money, the city or the county. All right, so that's just another application. Let's read this one. You'd like to have $4,000 in 4 years for a vacation. Maybe you're planning to get married, and this is the money that you're spending on your honeymoon, $4,000. That's pretty reasonable if you plan it yourself. But you want to save for it. And you don't want to take out a loan to go on vacation. You want to have the money available. So you're going to save, collect interest in what you save. And so that at the end of the 4 years, you have $4,000 so that you can just go on the vacation without worried about going into debt. You make deposits at the end of every 6 months. And so there'll be 2 different payments that you'll make in a year, one after the first 6 months and then the second one after the next 6 months. So you're making 2 payments. In an annuity that pays 7%, and there you see compounded semi-annually. So little n is 2, and that's also payments per year, compounding per year. Got to write it down. 4 years, P equals 4. Sometimes you'll actually see the numbers in there. Sometimes they'll spell them out. Got to read everything carefully. Okay, thank you. 8. 4 years times the n factor. Okay, present value is always 0 in these problems. We know that we want to have $4,000 in the end. If you take the future value, what you want to have in the end, and divide it by the number of payments you make, 4,000 divided by 8 is $500. So if you put the money in your mattress, you would have $500 that you would have to put in at the end of the first 6 months, and then another $500 into your mattress at the end of the next 6 months. So at the end of 1 year, you have $1,000. And if you do the same thing for 4 years, you'll have your $4,000. But you're not putting it into your mattress because you're earning interest. So you're putting it into an investment account somewhere. So your payments won't quite be $500. They'll be a little bit less than $500 because you'll be earning some interest to go along with whatever you put in there. So expect that this payment, and this is kind of the reasoning you want to go through, expect this payment to be a little bit less than $500. And to get it exactly, we use the TVM solver. And there it is. So no, it wasn't $500. We were paying ourselves interest. It looks like we were paying about $59, $58 in interest. So that extra 8 times about $58, $68. So in interest over those 4 years, you made about $480. Very nice. Okay, let's take a look at number 36. It's on the next page. The problem number 34 was very similar to the ones that we were doing. And they're always going to ask you, what is your payment? And then they're going to say, okay, of the future value that's in the account at the end, how much of that is what you put in there and how much of that is interest? So you can calculate how much you put in there because you just multiply your payment times the number of times you made it. Subtract that product from the future value, and you've got the interest. Okay. Here's a more realistic problem for you, number 36, because it talks about a 401k. And I just looked up the federal government right now will allow any American to contribute, well, I think there's probably some income limits there, but it will allow you to contribute $17,000 a year into your 401k. Suppose that between the ages of 25 and 37, you contribute $3,500 per year. All right, so the $3,500, it's not the amount you're going to have in the future. It's not the amount that you start with. It's your per period investment. It's your payment. It's your investment. And you're going to make it per year, once per year. So the payments per year, compounding per year is 1, and the payment is $3,500. I should probably read on and get all the information before I pick this up and start dumping numbers in there. But let's read on. Now, yeah, and your employer matches this contribution. And this happens a lot. If you get working for a corporation, sometimes they establish one of the fringe benefits is that they give you a 401k. And a lot of times they'll match it. Whatever you put in there, they'll match it up to a maximum amount. And this particular employer matches this contribution dollar for dollar on your behalf. So if you contribute $3,500, then what goes into your investment? So $7,000. This is 100% return for you. You put in $3,500 and your employer says, oh, okay, here's another $3,500. You're making 100% on your investment at the begin with. And that money is yours. You leave the company, it's yours. The interest rate is 8.25%, compounded annually. No more confirmation that the compounding factor is 1, compounded annually, 1 time per year. What is the value of the 401k? Okay, they're asking for the value of the 401k, that's the future value, rounded to the nearest dollar after, okay, here comes the 12 years. So here's where I have to take the number of years and then multiply by the compounding factor. Well, it turns out to be 12 because the compounding factor is 1. And once again, the only thing that, you know, the last blank that we have is the present value. And again, in all of these problems, we're assuming that we begin with nothing. And the only amount in our 401k is what we put in on our regular payments. I guess there are some situations where you get a signing bonus. And, you know, if they put your signing bonus into your 401k, All right. Okay, so we're on part A, and here's the work for that part. All right, so this is the one we want to calculate. I always stop and just kind of think about, well, how much probably is there? $7,000 for 12 years? 7,000 times 12, that's $84,000. Now, it's not a long number of years, so, but still, we probably should at least see that the money doubles over that time. So I would say that, you know, you're looking at about 170,000 or 180,000, because I know that it's going to at least double. But we'll calculate it. And no, it didn't quite double, did it? Well, anyway. Oh, yeah. I was thinking of something else. I was thinking if you had all the money up front, 84,000 up front, it should have doubled, but no. Okay, very good. 134, 825, and 66. Now they want us to round to the nearest dollar on this one, so we'll do that.
Why do you have a negative, Mr. Am?
On the 7,000?
No, on the answer, future value, where you wrote at.
Yeah. I shouldn't have. Thank you. Okay, now, after, which is often the case, particularly for millennials and others, I mean, I've been in this job at Delta College for, well, since 94. So it's now 30, is it 26 years? I think 26 years. But that's rare these days. Even people in my profession, they're leaving and going elsewhere. And so they say that now on average that you're going to have 5 full-time jobs on average in your lifetime, 5 different jobs. So you'll move. And a lot of times it makes sense to move because when you start working for an employer and they're just giving you a cost of living 2% per year, if you really want to get a jump up in salary, you look up what's out there and you might make a parallel move and get an additional $20,000 a year onto your salary. So look for those movements as well. So you leave the company and you move on to a new job. However, you keep the money in there. And I worked for some colleges when I was going through graduate school, and there was a 401k started there. That money is still there right now. It just continues to grow. I'm not putting anything else into those old 401ks, but it's still earning the 5 or 6% interest over the years. And that happens a lot. So how much money to the nearest dollar would you have in the plan when you reach age 65? All right, so we have to do some math here. Remember that our employee here worked from age 25 to age 37, and that was the 12 years, and then left. Now the same employee is going to work for how many additional years after leaving this company if this employee plans to retire at age 65? So 37 and then age 65 retire. All right, so do the subtraction. What is that, 25? 28 years. So that money continues to stay in that account. It starts off at 134,000 and then it remains in that account for 28 years. The same account earning 8.25% interest. All right, so here is the worksheet for part B. Let's assume that we're just going to compound the interest once a year. It's in the same account. There's 28 years. Interest rate is still 8.25%. We still want to know what the future value is. But what's different in those last 28 years is that you no longer work for that company. So you're not making any more contributions to your 401k of that company. Now, hopefully, when you move to the new company, you start up a new 401k and start contributing to that one as well. Well, what do you suppose we're going to put for the present value?
The present value.
I missed that, Tasha.
You said what are we going to put for the present value?
Yeah, see,
Is
we're
it
trying to calculate the future value, so we need to know what the present value is.
the one, the answer we came up with before, the 134?
Okay, good. So that's where we left off when we left the company. And that then becomes our present value in the next phase of the problem. And remember, this is an investment, so we're going to enter it in as a negative number. If you forget to enter it as a negative number, it's no big deal. It's just that when you calculate the future value will be negative. But if you remember the negative, then the future value becomes positive. So just plugging in all the relevant information, 28 and 8.5. Our subtotal from before is what we presently have in the account. Making no payments, and so if you don't even work after age 37, by the time you're 65, you will have amassed $1.2 million in that account. And 20 years earlier, it was only at $134,000. And again, this is a nice enough money that you can pay yourself $6,000 or $7,000 every month for the rest of your life, and you'll still have money left. And if you think about what you invested in this entire 40-year period, you put in 7,000. No, you put in 3,500, right? Your employer matched it with 3,500, but this is all you had to contribute for 12 years. That's it. And this is how much you end up with at the end. If you do the math here, this is going to be most of the time when students go through K through 12, they don't get a financial education. They don't learn much at all about finances. And so this is important stuff. This is real life stuff. If you invest early in your career, $42,000, particularly if you have an employer that is going to be nice and match that amount, your $42,000 grows to $1.24 million. So the best thing you can do when you have that job, and this is any 40-year period. It takes about 40 years to get to 1.2 million. So if you're older than 25, like our employee here, if you're 35, then you're going to have this money at age 75. And if you choose to retire at 65, you're not going to have this much money, but you're going to have a lot of money, because compound interest works whether you invest for 40 years or for 30 years. So what's important is put away money that you don't need, even money that you could possibly need to spend on other things, recreational things, and make sure, as they say, pay yourself first. And by that I mean pay yourself so that you're living comfortably when you retire. Okay. There's one other problem from this section that I thought I would do, just because it's really just arithmetic. You wouldn't use it with the TVM solver, but it serves as the basis for calculating interest and so on. And it says which annuity paid out the most interest over the term. And they give you 3 different loans, and they want you to calculate the interest, figure out which option gives you the most. All right, so I'll just kind of write them all out here. Annuity A, and then we've got annuity B, and then we've got annuity C. 1, 2, 3, A, B, C. Annuity A requires a payment of $150 per month for 10 years. At the end of the 10 years, the account has a balance of $21,000. There's no mention of an interest rate here. I suppose we know the compounding factor is 12 because we're making monthly payments. That's fine. In the next one, the payment is $1,000. And these are annual payments. So that means one per year. And this is for 12 years. And then the balance at the end is $16,000. And in annuity C, the monthly payments are $100, and we're doing that for 30 years. And then at the end, the future value is $41,000. Now, we don't need all the other information about the annuities. We have what we need in order to calculate the interest. I've given you this formula before, but I'll just give it to you again. All right, so the money that you have in the end, the future value of the annuity, equals the principal that you put into the account plus the interest. And the amount that you put in would be your payment amount times the number of payments. So it's arithmetic. They give us in part A, the future value is $21,000. Our payment amount for this one, we had a payment of $150, but we're making that payment 12 times per year because we're making it monthly, and we're making monthly payments for 10 years. So that is 120 payments, 10 years, 12 payments per year. So I think that's $18,000 if you multiply those two numbers, plus interest. So these are nice round numbers. All right, I'll say a little bit more about Wesley's, Cece's comment and Wesley's question here in a second. So interest must be $3,000. So there's the interest that we needed to calculate for part A. We do something similar for B and for C, and then we compare them all and compare the interest in each case. So B, we have $16,000 as the future value, and that's equal to, all right, so in this one, we're making one payment per year of $1,000. So we're making 12 payments of $1,000. So that's $12,000 that we would contribute. Sorry, you're not able to see that. The future value is $16,000, it's up here. And then we're making one payment per year for 12 years. So 12 times 1,000 is 12,000 plus the interest. All right, so you can see here that the interest must be 4,000. 12,000 plus 4,000 is the only number that would add up to 16,000. And then C, here's the information. By the way, unless they totally contrive these problems, or the longer time frame you have, this money is going to grow. So it's almost going to be certain that this one over here is going to be the one that is where you get the most interest. But you end up with 41,000, and you're making 100 dollar payments per month for 30 years. So that's a $100 payment times 360 payments. Monthly payments for 30 years. There's 12 payments, 12 monthly payments in 1 year. So if you do that for 30 years, 12 times 30 is the 360. So if you multiply these two numbers together, you have contributed 36,000, and everything else is interest. And again, they gave you nice numbers to work with. So 5,000. So you're even going to use these formulas in the earlier problems because they always ask you, how much interest you're going to make. And this is how you would do that last one.